Hi students, hope you all fine. So again I came with one more problem, or else you can say it is theorem or something, whatever it may be. Okay, let us discuss what it is. Okay, obtain the maximum estimate and moment estimate of parameter B of uniform distribution. So what they are asking is uniform distribution, we have to find out this parameter B. Okay, so what are the here they are not asking about the procedure. Okay, they are asking us to find out the B value by using maximum estimate and moment estimate. Okay, so now let's see how to calculate. Okay, yeah, so proof we can say, or else solution you can say, whatever it may be. Okay, yeah, MLE in the sense what, maximum likelihood estimate, isn't it? Maximum likelihood estimate, maximum likelihood estimate, and MME. What is MME? Is nothing but moment estimate, or else it is also, we can also call this one as method of moment estimate. So that's why I wrote, instead of ME I wrote MME. So moment estimate is also called as method of moment estimate. Okay, yeah, for the parameter what B. Okay, for the parameter B of what, uniform distribution, of a uniform distribution. So what are the given values here? 0 comma B. So now we have to find out this B value. Okay, so let's go through the steps for both the methods. Okay, let us discuss. Okay, first I'm going to tell about MLE. Okay, maximum likelihood estimate. So we are going to discuss about MLE. Okay, first step is, so we have to write the PDF. PDF in the sense what, probability density function we have to write for what, uniform distribution. Why? Because we are going to find out the parameter related to uniform distribution. So that's why we have to write what, PDF of uniform distribution. Okay, yeah. For a sample x1, x2 and so on xn, for a uniform distribution U with mean 0 and variance B. Okay, the probability density function, PDF in the sense what, probability density function is nothing but, probability density function is denoted with what, f of x. So it is denoted with f of x, no? So f of x comma b, that means we are going to find out b, that equals to 1 by b if 0 less than or equals to x less than or equals to b. 0 otherwise. Okay, 0 otherwise. So that means what, here the limits for x value is 0 to b. Whatever the b value comes, that is the limit, upper and lower limit for the density function. Okay, so if you don't get any positive, that means 0 to b, if you don't get, for example here we think b value is 2. Okay, so now if we take x value 3, it won't consider. Why? Because it should be lies between 0 to b only. So at that time we can directly keep the value is 0. Okay, yeah, that is the meaning of this. And next what we have to do is, now we know what is PDF. Now we have to write likelihood function. Okay, yeah, the likelihood function L of B. Okay, why? Because we are going to find out this B, no? For a sample of size what, n, sample of size n is nothing but L of B, x1, x2 and so on up to xn equals to what? For this value we have to keep 1 by b to the power of n. Why? Because if we keep x1, this one only keep. If we keep n value 2, again this term will come. N value 3, again this term. So n value, there are n terms. So that's why I kept here 1 by b to the power of n. Okay, so this one we can write, if 0 less than or equals to xi less than or equals to b. For all I equals to what? 1, 2 and so on up to n. Equals to 0 otherwise. Okay, now we know what is likelihood function. So now what we have to do is we have to fix the b value. So what the b value? We have to fix it. Step 2. Okay. Yeah. So this one we call it as a support of likelihood function. We call it as a support of likelihood function. Or to know the value of b in likelihood function, you can also write like that. Okay. So it should be non-zero. Non-zero means what? It should be greater than 0. That means positive values b value should be. Why? Because it lies between 0 to b. No, so compulsory it will be greater than 0. Okay. Yeah. The likelihood function. The likelihood is non-zero. Non-zero. Only if b greater than or equals to what? Maximum of x1, x2 and so on xn. Okay. So b value will be what? Greater than these maximum values. Okay. I'll explain you this one with an example so that you will understand. Okay. Yeah. Let xn be the maximum value. Okay. Be the maximum value in the sample. Okay. I'll explain you with one example so that you will understand. Okay. Next, third step is, now what is that maximum value? We have to write. Okay. Maximize the likelihood function. Likelihood function. So let me tell you. To maximize L of b, that means this function only we have to maximize, no? So here we are having, no? So this function only we have to maximize. Okay. So to maximize L of b, we need to choose what? Maximum value. We need to choose the smallest b value. Smallest b that satisfies what? The condition. Okay. That satisfies the condition b greater than or equals to xn. Okay. And this gives what? This gives us finally the estimate b value by using maximum likelihood estimator equals to xn. So like this we will get the maximum likelihood estimate. By using this method we get the b value. So let me explain with one example. Okay. So see here. First step I am going to explain. See, practical purpose. That means in order to understand the procedure clearly, I am going to explain you with one practical example. So here sample values. Here we have to take what? First sample values. No? So let me take the sample values. Maybe 2, 5, 3, 8, 4, 6 like that. Any one number of samples you can take. Okay, but it should be finite sample. So next xn values. What this is the first step. Okay, now here we took sample values. Okay, next second step. What is second step? Here we have to find out what? Maximum value. That is nothing but xn equals to, what is the formula here? Maximum of x1, x2, x3. That means what? These are x1, x2, x3 and values, no? So that means what? Maximum of 2, 5, 3, 8, 4. So what is the maximum value here? 8. So the third step is nothing but b value equals to xn. So what is xn here? B value equals to xn, no? So what is xn here? 8. Isn't it? Okay, how this b greater than or equals to maximum will work? So let me explain this second step clearly. For example, here we have taken x1 equals to 2, x2 equals to 5, x3 equals to 3, x4 equals to 8, x5 equals to 4. Okay, let me explain only this, b greater than or equals to maximum. First I am going to compare two elements. Okay, so first comparison, compare x1 equals to 2 with what? x2 equals to 5. So like that, if you compare and if you see this inequality, b greater than maximum, so b greater than maximum of what? 2 comma 5 now. So what is here now? B maximum value is nothing but 5. So that means here the b value is 5. Okay, again let me explain. That means we have to check everything. Now what we have to compare in the next is x2 equals to 5, x3 equals to 3. So now b greater than or equals to maximum of what? 5 comma 3. So that means what is b here now? Maximum value is 5. That means again b value equals to 5. Again what we have to do is, again we have to compare with x3 and x4. So x3 is 3. What is x4 value? 8. So b greater than or equals to maximum of what? 3 comma 8. So now b greater than what? Maximum value is nothing but 8. Okay, so like this we have to compare. So how much? So at last we will get this value only. Okay, at last we will get this value only. So see here, we got in 2 steps 5. Here we got 8. Okay, here 5, here 5, here 8. And maximum in this is nothing but 8 only, no? So that's why finally we will get the value 8. So that is the meaning of this step 2. Okay, hope you understand. Okay, now let me explain the other method. That is nothing but, what is the other method is movement estimate. That means MLE, movement estimate. MLE. Okay, MLE. So MLE is nothing but method of movements. Okay, method of movement estimates. So here first what we have to do is, we have to determine the movement. So as we discussed in our previous videos, so nothing but here the central movements, non-central movements. Okay, we will remember, I told you. Okay, yeah. So first what we have to do is, we have to determine the movement. First step is we have to determine the movement. So nothing but mean. We are going to determine what? First step, mean. Yeah. The first movement is nothing but mean of a uniform distribution U with mean 0 and variance B is nothing but expectation of x equals to, here what we'll get is b by 2. So this is the formula, Nana. You may learn second semester. Okay, na? Uniform distribution mean value is b by 2. So it will be in our second semester. Okay, so next second point is set up the moment equation. So what we have to do is, here we have to find out the equation. Okay, so set up the moment equation. So that is nothing but expectation of x formula. What is the expectation of x? Expectation of x is nothing but x bar. So expectation of x is nothing but 1 by n summation xi, isn't it? So this is the formula, nothing but we are going to write the mean formula. This is the formula for common to every distribution. Okay, but this is a mean for only uniform distribution. Okay, so that is the difference. Next, third one. Now we are going to find out what? B. Okay, solve for B. So we are going to find out what? B value. Solve for B. So now what we have to do is, now we have to compare these two. Okay, yeah. Set the sample mean equals to what? Theoretical mean. That means this value. Or else we can say general mean formula. Set the sample mean equal to the theoretical mean. Okay, and solve for B, and we have to solve for B. So that is nothing but here x bar, no, b by 2 is nothing but x bar. So x bar equals to, this one also we call it as an x bar. So x bar equals to b by 2, isn't it? So Nothing but here cross multiplication. If we do cross multiplication, 2x bar equals to how much here? B. Okay, so that means if we know the mean value, so that we can able to find out the B value. Okay, so this is the formula. So like this we can estimate B value. So let me explain with one example. So therefore BME, that means B value by using method of moment estimate equals to 2x bar, where x bar is nothing but x bar equals to 1 by n summation xi. Okay, let me explain one example. The same example which we have seen before. So x1, x2 and these values are the sample values. Now we are going to find out x bar. So x bar is nothing but 2 plus 5 plus 3 plus 8 plus 4 by how much? 1, 2, 3, 4, 5, no? So 5. So that means x bar value will get how much? Here 5, 6, 7, 8, 9, 10, 18, 19, 20, 21, 22. 22 by 5. 22 by 5 is nothing but we will get 4.4, isn't it? So B value is 4.4. So now what is the formula here? X bar equals to B by 2 now. So x bar equals to B by 2. So that is nothing but 2x bar equals to B. Isn't it? So now what is the x bar value here? 4.4. So 2 into 4.4 equals to B. So therefore B value equals to how much? 8.8. Okay. So if you observe in previous, in this method, maximum likelihood estimate we got here B value as 8. In this method we got how much? B value as 8.8. That means near answers we will get. Whatever the method we perform, the near answers we get. Okay. So this is about the procedure for uniform distribution in order to find out the B value by using maximum estimate method and moment estimate method. Hope you all understand. So please like the video mass. So just simply seeing. Please, if you like my explanation, please click on the like symbol, share with your friends and don't forget to subscribe. If you like the video, it will reach to the students who are in need. Okay, so please subscribe. Hope you all understand and comment which videos, which type of videos you want, at which point you don't understand and what the videos you want me to make. So comment all those things. Okay, thank you. Have a nice day. Hope you all doing great. Bye. Take care.